Good afternoon, and today we are going to do our final interactive video on instant ice. The materials that we're going to use are going to be purified water. I have 4 bottles of purified water, and we're going to put them in the freezer for 2 hours and 45 minutes. Come back, and then once that is complete, we'll go ahead and start with the experiment. Just wanted to show everyone the bottles of ice. That once that's been in there for 2 hours and 45 minutes, we'll see what we can do. Okay, we're going to have a little bit of editing magic. I'm going to get the supplies one at a time so I don't accidentally drop one bottle and have to start the process all over again because it's been 2 hours. So I'm going to go ahead and get the first bottle. The first bottle we're just going to like thump and it should freeze. I'll be right back. The several experiments that I tried did not work, and with time getting to be where it is and the amount of time that we have to wait to test out each successive experiment, I'm going to go ahead and explain what should have happened and why those things happen when they happen. From the research that I've done, a lot of this is time and temperature based. The refrigerator, I played with the different settings to see if for this set of hours it would be one way or another. I even tried an alternative experiment because I didn't have a digital thermometer, but I did have a mercury thermometer, which you couldn't watch inside the freezer. But I did the bucket of ice. You put the salt around the ice, you wait for it to get about -8 degrees, and take it out. And in all the different cases, what should have happened is if you flick the super cold or the super cooled water, it causes it to crystallize and turn into kind of a slush. And there's other little things that you can do, like build the slush as you pour it, or if you add the ice. And that is because the ice, water as ice in that crystalline structure, has less energy than the molecules as a liquid. So it can move from a liquid water state to a solid water state. Um, they have to lose that heat. So when you tap it, it also warms the rest of the water. The heating allows about 10 or 20% of the water itself to freeze, and so that's why it's more slush. But you can see that crystallized structure as it continues to go down. So it's forming those little crystals, and it needs some type of microscopic impurity to attach to. When an impurity, such as an ice crystal, is added to the supercooled water, this also speeds up that crystallization process even more. So the water instantaneously freezes. And that is why when you see the snap freezing effect, when in the example video, you had the super cool water and you put like one ice cube in it and all of it turned solid. So this is the reasons why. The reasons why it didn't work. And that we're talking about like temperature, control of the experiment, the effect of the container itself can come into play. There's a lot of things that need to be controlled. Are you outside? Are you inside? How how much heat is in the ambient environment. Uh, there's things such as I didn't have the digital thermometer, so I could only kind of guess at which setting what temperature was what. Also, I have bags of ice and a full freezer. I tried to have it's a standalone, or not a standalone, but a an upright um, double door. So there's not a whole lot of room to move things around, and so I'm wondering if there were any like cold spots with various temperatures. I couldn't put things directly away from the actual output kind of fan mechanism because then it would be directly on frozen items or ice, postulating of what went wrong and what we discussed what should have happened and then why what should have happened happens. That is my video for this week, and hope that you all enjoy the rest of your time, and thank you for letting me be a part of this.